This is worksheet 4 of the Covalent Compounds packet, and this is where you get the rest of the story. Okay, so far in worksheet 3 we learned how to draw covalent bonds that actually are called single covalent bonds. So two atoms share one pair of electrons. There's one line in between the two atoms. All right, and 90% of the time, that's it. That's all you're going to need. But every once in a while, you come to a situation where you need to use either a double bond or a triple bond. They're still covalent bonds, right? These are all types of covalent bonds that represent sharing electrons between atoms. Okay, we'll talk about double bonds, then we'll talk about triple bonds. In a double bond, you run into a scenario where you've gone along connecting atoms with single covalent bonds, one line between them, and you get to the end and you've used up all the valence electrons that you have, and there's one or more atoms that are left without 8 electrons around them. And you can't just stop, you gotta do something. And the something that you're gonna do is called creating a double bond, which I'll show you in a moment. But there's something important to remember. The thing you need to remember, there we go, is that double bonds are much stronger and bond the atoms much closer together than a single bond, which means they require a lot more energy. And remember that we've learned again and again that electrons and atoms, much like people, they don't want to do something that requires more energy unless they have no other choice. So when you're drawing covalent bonds, I want you to work under the assumption to begin with that you're going to just be using single bonds, and only if you run into a choice where you have no other option do you use either a double or a triple bond. And I'll give you an example when you run into that situation. Let's look at carbon dioxide, CO2. I'm going to draw this assuming that single bonds are going to work. That's how I'm going to approach this, because that's how I want you to approach these, because pretty soon you're going to get all these different types of situations mixed together. Okay, I know this is on a double bond worksheet, so it's kind of a spoiler alert. So, we start off the same way as we would on worksheet 3. We're going to add up how many valence electrons total we have for carbon dioxide. Carbon's in the 4th family of the periodic table. There's just one of them. Oxygen is in the 6th family. There's 2 oxygens though, right? So we multiply that by 2. So 12 plus 4 gives me 16 electrons to work with. I can't go beyond 16 electrons in my drawing. Carbon's going to be my central atom because there's only one of them. And I'm going to connect the carbons and the oxygens together with single bonds. Remember, I'm assuming single bonds are going to do the trick. So I've used a total now of 4 electrons because each of those lines represents 2 electrons. So that means that I now have 12 electrons left. Next place I put my electrons is around my central atom, trying to get 8 electrons around it. So it's already got 4 around it, those single bonds. 5, 6, 7, 8. Okay, so I've used 4 more electrons filling carbon, which means now I have 8 electrons left to go. So I'm going to divvy them up around my outer atoms. So 1, 2, 3, 4, 5, 6, 7, 8. Remember, I put the electrons on in pairs, and I try to spread them out as evenly as I can around the remaining atoms. Now I've used up all 8 of those electrons, right? If I counted up all the electrons in this picture, I used 16, which means that I can't put any more electrons into the picture. But we've got a problem. If we do a total electron count on this one oxygen, there's 1, 2, 3, 4, 5, 6, right? It doesn't have 8 electrons around it, neither does this one. 1, 2, 3, 4, 5, 6. They only have 6 electrons around them and they want 8. Okay, now some people might rush and go, oh, okay, I'll put 2 more here. Look, now oxygen's got 8 around it. Nope, you can't do that. Why not? Because you didn't have more electrons to work with, right? You'd already used up all your electrons. So this is a case where you're going to create a double bond. So Doesn't matter which oxygen you start with. Let's start on the left. This oxygen is going to say to the carbon, hey, I notice you have all 8 electrons. I don't. Would you mind sharing some more electrons with me? And carbon's very friendly. It's going to say, oh yeah, no problem, man, I'll share with you. And it's going to share a pair of electrons. And it doesn't matter which set of electrons you use, the ones on top of the carbon or the ones on the bottom. Let's do the ones on top. Okay. These 2 electrons, carbon's going to just shift over here. And it's going to create, with those electrons, another shared bond. Alright. And so, we got to erase those from the picture. Okay, it's not going to let me erase them, so I'm just going to cross them out. Those electrons aren't there anymore because they've moved into the so-called double bond. Okay, so this oxygen over on the left is happy now. It's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. Yay, happy oxygen. Okay, but this oxygen over here, it's still not happy, so this oxygen is going to do the same thing as the other one. It's going to turn to carbon and say, hey, carbon, I notice you've got 8 electrons. Because carbon still does, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay? It didn't lose electrons by sharing them with oxygen. So this oxygen on the right is going to say, hey, carbon, could you share another pair of electrons with me so I can have 8? Carbon's very friendly. It's going to say, yeah, sure, no problem, man. I'll bring these down here. We'll just put them right between us. Okay? So now we got to get rid of those electrons, which of course my little program won't let me do. Oops, let me cross that out. So I'm just going to cross those out. Those aren't there anymore because they're part of the double bond. Okay, and so now all of the atoms have 8 electrons around them. They're all happy. So I'm going to redraw this because it got a little messy. Here are my double bonds, right? Each bond counts for 2 electrons. And then this has 2 and 2, and this has 2 and 2. And there's my final drawing. Okay? So, this is what you're going to be doing. Now, I want to help you. There's a couple here that aren't super obvious because they don't have central atoms. So, I'm going to give you just sort of the skeleton structure to get you started so you know which atoms connect to which. But don't think I'm giving you the answers, because you still got to total up your valence electrons. You've still got to put in single electrons and bonds and all that. Okay, but for oxygen, remember, they'll just connect like this. There's no central atom. For ethene here, this is what this is telling you. The C's are central, so I've got 2 carbons that connect. Okay, and then I've got 4 hydrogens. So I have one here, one here, one here, and one here. Okay, now that's not a finished picture. You got to keep going. Alright, but you do that when you get to class. Let's talk about triple bonds and do an example together. Okay, with a triple bond, again, the triple bonds are even stronger than double bonds, and the atoms are held even closer together. So this is like a worst case scenario. Assume single bonds are going to do the trick. If they don't, resort to double bonds, and if that still doesn't do it, then if you absolutely have to, triple bonds. Okay, so let's look. Nitrogen, N2, okay, so nitrogen's in the 5th column, and there's 2 of them. So that gives me 10 electrons to work with. Okay, there's no central atom, so I'm just going to connect my nitrogens together, which means I've used 2 electrons so far, which means I have 8 left. So now I'm just going to divvy those up as evenly as I can amongst the nitrogens. 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay, so I've used up all 8 of those electrons. I don't have any more electrons left now. So I can't just go putting more dots in the picture, but I got a problem because each of my nitrogens only has 1, 2, 3, 4, 5, 6 electrons around it. So, one nitrogen's going to turn to the other, and it doesn't matter who turns to who, right? One nitrogen's going to say to the other, hey, I think we need to share some more. Okay, let's share some more. And it really doesn't matter which pair of electrons you pick. Let's take this pair, move them into the center, make a double bond. Okay, so let's erase what we can. It's nitrogen there. Sorry, that's messy. And now we're going to look and see if that did the trick. Okay, so if we look at this nitrogen here, it's got 1, 2, 3, 4, 5, 6 electrons. Yep, so that one's still not happy. What about this one over here? 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, so this nitrogen's happy, but this one here isn't. So what can we do? Well, we better get the nitrogen that is happy to share. So again, it doesn't matter which pair you take. Let's take this pair from the happy nitrogen. It's got to be a pair from the happy nitrogen, right? You don't start sharing until you got enough yourself. Okay, and we're going to move this pair over here. We're going to create a triple bond, which is kind of crazy. Okay, and remember that means that these really aren't here anymore. Okay, and now let's look. Nitrogen is 1, 2, 3, 4, 5, 6, 7, 8. And this one has 1, 2, 3, 4, 5, 6, 7, 8. This one's happy too. Yay! You don't have to draw the smiley faces. Duh. Okay, so that means we're good because we've only used a total of 10 electrons. We haven't used more than we were given, and we have gotten 8 electrons around all of them. So I'm going to redraw it since it got a little messy. And there's my final picture. So you're going to try to do the same down here with ethene. Okay, what they're telling you is the carbons connect, and then the hydrogens connect to those. So that's your basic structure, not your final answer. Alright, you keep working on these, and we will take a look at what you did when you get to class.